All right, I think we're ready. Welcome, everyone. My name is Bradley Flam. I'm the director of the Office of Sustainability here at Westchester University. And I'd like to welcome all of you who are here in person and those of you who have logged on via the Zoom room to this, the fourth presentation in our fall 2023 our fall 2023 Sustainability Research and Practice Seminar. We're very happy that you've joined us today. Please remember that we have talks in the seminar series every Wednesday at noon through November 15th, I believe, in the semester. So there are 6 more talks. Please join us for all of those. You can find a full program on the Office of Sustainability's homepage for the presentations that are going to be coming up, including next week, Professor Joey Miller of the Philosophy Department here in the audience will be speaking. For now, please join me in welcoming Professor Elliott Arnold.
Thank you. Thank you. So this talk should last for between 30 and 40 minutes, and I thought I'd start out by introducing myself. I do actually recognize almost every single face here, save for maybe one, but I am a geochemist, and I use biomarkers, which are chemical remains found in the sediments of lakes and the ocean to reconstruct climate. And I'm particularly interested in reconstructing climate during intervals of societal collapse, because a large part of me, the neurotic part of me, or perhaps the realistic part of me, sees parallels between ancient societies and their collapse and our current modern era. And my most recent work has focused on an interval of time called the medieval climate anomaly, which began around 900 AD, and it lasted for 200 to 300 years, depending on who you ask. And this was the time of tremendous change on Earth, natural change on Earth. And it's associated with the collapse of several prehistoric, I could call it, so these societies didn't have written records, but prehistoric societies. I'm going to focus on 2 in this talk. The Tiwanaku, which is a society in Peru, and these are the remains here of the Tiwanaku capital in the Titicaca Basin of southeastern Peru, northwestern Bolivia. And today it's like a religious pilgrimage site for people who are Quechua speakers in Peru. Getting back to this medieval climate anomaly, I mentioned that it was like a natural change in Earth's climate system. More specifically, what it represented was an increase in temperatures across the globe. So it was a period of elevated temperatures where some parts of the northern hemisphere were warmer or as warm as they are today. So that means at 900 AD, some parts of the Earth were actually warmer than they are today. And that's pretty striking given the amount of CO2 that we put into the atmosphere during and after the Industrial Revolution. So this figure here shows reconstructed surface temperatures, and all the areas in red and yellow and orange are warm temperatures, and the areas in blue are slightly cooler temperatures. And this is from the period of the medieval climate anomaly. So you'll see most of this northern hemisphere region here was anywhere between 0.5 and 1.5 degrees Celsius warmer than the intervals on either side of it. So it was a period of warmth and elevated temperatures in the northern hemisphere. And to put this into perspective, temperatures in England and most of northern Europe, for that matter, were higher during the medieval climate anomaly than during this period, 1961 to 1990. So this graph here shows temperatures from the year 1000 AD to present. And the y-axis here shows the temperature relative to the average from 1960 to 1990. And this dashed line here with the dots in the middle represents the climate of central England. And you'll see that during this medieval climate period, the temperatures in central England and all of England for that matter were almost 0.5 degrees Celsius higher than the average temperatures recorded during the industrial era, or what I would call the modern era, even the post-nuclear era. And that was true for almost all of the sites that were measured in this study. So sites in the northern hemisphere were higher at times during the medieval climate anomaly, and the entire extratropical northern hemisphere was also warmer during this period. And as a result, there were major changes to society during the medieval climate anomaly. So if you're going to warm up the planet even by 0.5 degrees Celsius, you're going to change the biology. You're going to change the distribution of trees. You're going to change migratory patterns. You're going to change precipitation patterns and weather patterns. And as a result of those changes, agriculture was actually possible at higher latitudes and altitudes during this era. And we know this from written records in Europe. Grapes were grown in England, olive and fig trees were grown in southern Germany. And we actually know this through artwork, believe it or not, but mountain glaciers actually retreated during the medieval climate anomaly. So similar things are actually happening today as well. The vineyards in southern France are creeping further and further north, and they're even crossing the English Channel now. So wine is being grown in England now today. We don't quite have olive and fig trees in southern Germany yet, but I have a feeling that's coming. And almost all of the mountain glaciers in Europe have retreated during the modern era. And historical documents indicate that records of frost dates, freezing of water bodies, snow cover, the dates of flowering of plants, all together indicate that severe winters were less frequent and less extreme. So we had a change to the climate, and we had a change to the society at this time. But I think one of the coolest, most memorable archaeological, or I should say societal events during this period was the expansion of societies. So it was during the medieval climate anomaly that the Vikings sailed across the Atlantic and settled in Greenland. They actually settled here in southern Greenland and a portion of the western part of central Greenland. And this was only possible because the climate warmed enough to support agriculture in Greenland. So these were really some of the first settlers of what I would call the New World, although they didn't go all the way over. However, there is evidence for them in Nova Scotia as well. But these folks expanded because of the equitable or amenable climate. And I won't go into all the scientific details behind these things because I want to keep this as a more generalist talk. But we can relate societal growth to environmental changes through studies of lake cores. And my friend at the University of Pittsburgh, which is where I did my postdoc, did a study of a core of a lake in Greenland. And he actually looked at the head casings of larval insects. They're called chironomids. Some people call them chironomids. I was always taught chironomids. But he actually looked at the durable head capsules of these chironomids that are trapped in the sediments of lakes. And he extracted these chironomid head shells from the sediments that were associated with the medieval climate anomaly. So this warm period when Greenland was settled by the Vikings. And he found, based on chemical reconstructions stored in the head capsules of these aquatic insects, that the temperature during the medieval climate anomaly, which is indicated here by this yellow bar in the graph, I guess I should highlight it on mine for the folks at Zoom, highlighted here by this yellow bar in the graph, warmed by about 1 degree Celsius over that interval. So here is in the red, his study that shows the temperature change from 500 BCE to present, and you'll see there was a significant warming spike that occurred during the medieval climate anomaly. And he reconstructed this warming through these insect larvae, and I thought that was pretty amazing. It was a great study that he did. But this medieval warm period only lasted for a short period of time. Shortly after the medieval warm periods, period of warmth here indicated by the blue, temperatures decreased rapidly. They dropped by about 1 degree Celsius relative to the 1961 to 1990 average. And this period is known as the Little Ice Age. And it had an equally profound impact on society. So we had the medieval climate anomaly from about 900 AD to 1200-ish AD. And immediately after that, we have the Little Ice Age. And just like the medieval climate anomaly caused changes to society in Europe, so did the Little Ice Age. There were harvest failures, they were widespread, the price of grain increased, birth rates dropped, and death rates, of course, increased. And during the interval of 1314 to 1315, so a few hundred years after the onset of the Little Ice Age, the population of Northern Europe died from, or 10% of the population of Northern Europe died from starvation. 10%. And do you know what came right after this, about 30 years after this? Any history buffs here? That knocked out about 2/3 of the population? Yeah, the Black Death. And they think that may have been caused by climate as well, because it related to, well, I don't want to get into this, but the Black Death was spread by fleas. It was like a flea-borne disease. They rode on the backs of rats, and the rats spread the disease to humans. But anyways, the Little Ice Age was really rough in Europe. This is a picture of the Thames River in England, in London, and it froze solid during the period 1310 to 1350 every winter. And they set up a fair, like a market and a fair in the middle of the Thames River. And if you've ever been to England today, you'll know that it's a relatively equitable, moderate climate. Like it's always like 50 degrees and cloudy and rainy, right? It doesn't snow much in England. It also doesn't get really hot in England either. But during the Little Ice Age, it was more like Canada. As a matter of fact, it was more like northern Quebec. You could picture this being like the St. Lawrence River flowing in front of Quebec City today. It was frozen and it was cold, and a lot of people died as a result of the Little Ice Age. And this is when the Norse settlement in Greenland was abandoned, because agriculture was no longer tenable. Meaning they couldn't grow crops anymore. It got so cold. So it certainly changed societies. And I told this story in my class, Humans and the Environment. There was actually one positive outcome of the Little Ice Age. Because it was so cold, trees grew a lot slower during the Little Ice Age, and their rings became densely packed together, because the width of the tree rings actually is impacted by the growing season, the temperature, and the levels of precipitation. So when it was much colder, these densely packed rings made really dense wood. And that's when these Stradivarius violins were made during the Little Ice Age. They can't reproduce that now, by the way, because it was literally the result of the Little Ice Age, and we can't reconstruct that climate today. So one positive outcome of the Little Ice Age. So what we see then is a major climate transition, and just follow this broad trend in this figure. It goes from a relatively cool period just prior to the medieval warm period to a relatively warm period globally into a very, very cold period just after that. We have a transition from, I guess, a normal climate state during the Holocene, which is the current era we're in now, to a relatively warm period to a relatively cold period. Here is where we are today, by the way. And this is actually in 2016. So changes to Earth's system would have an oversized influence on people, especially agriculturalists in this area, living in dense settlements, because agriculture is tightly coupled to climate, right? Especially when you don't have high-tech agricultural society where you could use technology to buffer against changes in the environment that obviously didn't exist back in the medieval climate anomaly. So getting back to that again, I'm focusing on precipitation with all my research. And what this figure here shows is a map of the globe and areas where precipitation has changed, or where we've measured a change in precipitation during the medieval climate anomaly. And the red areas are places that got really dry during the medieval climate anomaly. And the solid blue areas are places of increased precipitation during the medieval climate anomaly. And a lot of these red circles actually overlap with major civilizations that collapsed right around this time. We have, from left to right, the Maya civilization. During the medieval climate anomaly, the golden age of the Maya ended. The Moche, or the Wari civilization in northern Peru, vanished, essentially. I hate to use that word because I'm like sensationalizing it, but we don't find any record of their society after the medieval climate anomaly. The Tiwanaku, which is the society that I study, we see a drought record all along the coast, actually, of the Andes down to Chile, which is remarkable. Angkor Wat, is anyone a fan of the Tomb Raider video game series, or have you ever seen the movies with Angelina Jolie, isn't it? Yeah, Angelina Jolie, that's Angkor Wat. It's an amazing civic ceremonial center in the jungle of Cambodia. It was a truly remarkable city. They think it may have had over 100,000 inhabitants at its peak. And that society, the Khmer society at Angkor, abandoned the site during the medieval climate anomaly. And the Tang dynasty in China also met its demise during this time. So we have what I would say no coincidence. We have at least 4, maybe 5 major collapses of societies during the medieval climate anomaly. complete abandonments of their cities, complete abandonment of their artwork, of their pottery regimes, of their megalithic carvings, so like the stone structures that they literally put up and carved to just show everybody how great they were. All that stuff vanished during the medieval climate anomaly. And what I'm arguing is that precipitation regimes were critical to this collapse. And this is the one bit of science that I want you all to take home from this talk, because I think it's going to screw us up in the future today. Like us, it's going to impact us very soon. Actually, it already is. And it's called the intertropical convergence zone. It's a mouthful. But what is the intertropical convergence zone? Actually, before I tell you that, I'm going to tell you what causes precipitation in the tropics. Sea surface temperatures. Sea surface temperatures are tightly coupled, meaning they're linked to precipitation. So you know hurricane season. We're actually in hurricane season now, right? If you were class, I'd ask you, does it require warm sea surface temperatures to form a hurricane or cold? And you would all say warm, because you just are listening to everything they say in class and you're really, really interested. But the better question is why? Why are warmer sea surface temperatures associated with hurricanes or increased precipitation? And the answer is because it drives evaporation. Greater ocean temperatures transition more water from the ocean, from the liquid phase to the vapor phase. You can think of a cup of water. If you set it outside on a really hot day, it's going to evaporate. It might take the whole day to evaporate, or maybe a couple of days, but it will evaporate. If you did the same thing on a cold day, it certainly won't evaporate. It might even freeze if it's cold enough, right? So temperature is linked to precipitation through evaporation, or rates of evaporation. And the most important precipitation regime on Earth is called the ITCZ, the Intertropical Convergence Zone. This is where the trade winds meet. It's also the area of most intense incoming solar radiation. So the ITCZ in this figure here is indicated by the red, and for those on Zoom, by the red band and the blue band here. And its position changes based on the temperature of the Earth. So it roughly is tracking where the equator is, right? But it moves slightly to the north during the summer, during our summer, and it'll move to the south during our winter. And that's because our hemisphere is warmer during our summer. So the ITCZ moves to the north, and it's colder during our winter. So it moves to the south, because the southern hemisphere is experiencing summer when we're experiencing winter. And this is essentially just a band of precipitation. So do I show it? You could look at a picture of the Earth today from a satellite image and see literally a band of clouds that almost follows the equator. That's the ITCZ. That's the zone of intense evaporation and precipitation in the tropics. And the ITCZ is responsible for the seasonal pulses of precipitation to all of these areas that are near it. It just so happens that these areas are also right on top of or right adjacent to these societies that collapsed during the medieval climate anomaly. Now, I added a couple extra circles here for effect. This is Mesa Verde, the Puebloan society, but here's the Maya, here's the Tiwanaku, here's Angkor, and the Tang dynasty would be right here. Of course, the Moche and Wari would be right here. So shifts in the ITCZ will change the amount of precipitation that these societies receive. And remember, back in the day, we're talking about 1,000 years ago, precipitation was crucial for state level society. And what that means is that civilizations relied on agriculture for their food. They were no longer hunter-gatherers, right? They were sedentary agriculturalists. And to water the crops, they needed rain. They needed irrigation systems. They needed a ruler to build them and to manage them. So civilizations that are located near the periphery of the ITCZ will have either excess precipitation if the ITCZ moves directly over them, or aridity and drought if the ITCZ moves to the north or south of them. So the shift of this ITCZ says a lot about precipitation in this region. As a result, it says a lot about the state level hierarchy, because it was dependent on these irrigation systems. And here's the last part of the talk. I just want to show you some results from my study in the Central Andes. This is the Altiplano of Peru. These are the llamas, the only large domesticated animal in the New World, by the way. They had them. They were draft animals. They were used for food. They were used for currency. They were used for clothing, shelter. It was so important for them. And they grazed in an area called the Altiplano, which are the high plains of Peru. You see, there's not a lot of trees here. There aren't any trees here, actually. It's been deforested. Back in the day, there weren't many trees either. It's a desert, but it's also green. You know, it gets a lot of rain during the rainy season. But it's about to change in this story. The Tiwanaku developed around 500 to 600 AD, and they flourished as one of the first large states in the Andes. This is the location of the Tiwanaku homeland on today's map. Up here's the Wari and the Moche, the other civilization that collapsed around the same time. And the Tiwanaku has served as an inspiration for modern Peruvian culture. Well, I say it served as an inspiration to Inca culture, and by extension, modern Peruvian culture. We find archaeological evidence of Incan pilgrimages to this site back during the 1300s, the early 1400s, late 1300s. And people still go there today to make offerings, to pray, to meditate, to do other things that they do in Peru, to expand their minds. It's an important site, is what I'm getting at. And the story of the collapse of this civilization, this is the Gate of the Sun. It's pretty spectacular. It sits in the middle of an island that's in the center of Lake Titicaca. But the story of their collapse was the first case of these cases to enter the scientific literature. Like, people really were mystified as to what happened. There wasn't written records like there was for Rome. They didn't know what happened. And it began right around 1000 CE with the fall of the political regime and the cessation of monumental construction. That's how we realized it happened. So I wanted to ask in my research, how might environmental change be related to these shifts in society in Peru? And can we relate this history of drought from lacustrine sediments? And you can ignore the rest, but can we reconstruct the drought based on chemicals that are stored in the sediments? So I went down to Peru, it's been just before COVID. So it's been like 4 years now, 5 years. And we went into the middle of this lake here, and we stuck a tube in the water, and we pushed it all the way down into the sediment, and we pulled it up. And we literally got a record of the environment from this core, from this lake core. This is the sediment core, and each layer here is dark light, dark light. Each layer here represents a year or a season of environmental change. And we narrowed in on the interval of the medieval climate anomaly in this lake core. And a quick aside, we got all of our pouring equipment stolen when we were in Peru at the lake by the people that live there. And I don't blame them for stealing it. Let me tell you why. The oil companies started drilling in the area. And you know, the people that live near this lake that we cored, that was near Lake Titicaca, you know, they're not, they do not, I should say, distinguish between us coring the lake and the oil companies coming in and coring, you know, the ground for oil. And those oil companies are, if I can use a bad word in this talk, a moderately bad word, they're assholes. Because what they do there is they drill for oil, they find oil, and they don't hold themselves to the same environmental standards in Peru as they would in the United States. So they degrade the landscape. And the people there realize it. Like, we get our fish from this lake. You know, why is it so disgusting now that you left? Why is there a pool of less dense oil sitting on the top of our lake here? And, you know, they don't have to do anything. They don't have to compensate those people, and they very rarely face any legal consequences for that. So they thought we were doing the same thing. And they're like, no, we're not letting this happen again. And they took our coring equipment. I was like, I'm a scientist. Wait, I'm a scientist. Look at me. Like, I had holes in my pants, and I'm not working for an oil company. They didn't believe me, probably because I wasn't saying it in Spanish. But you know, they didn't believe me. It was sad, but we got one core before they took our equipment, and that one core was enough. Ignore this for now. Folks on Zoom, ignore this for now. That one core was enough to reconstruct the precipitation regimes in that region during the medieval climate anomaly. What we did is we used a biomarker in the lake, so a chemical compound in the lake that indicated if the lake was full or if the lake was less full. And what do you think really drives the fullness of a lake? Rain. Precipitation, or more specifically, the ratio of precipitation to evaporation. When it's drier, the lake level will be really low because there won't be much precipitation going into the lake. there'll be a lot of evaporation causing the lake water to lower. And when it's really wet, there'll be a lot of precipitation in the lake and less evaporation. So we found a biomarker that using a compound in the sediments of the lake that could indicate changes in this precipitation evaporation regime, which is pretty cool. And we developed a hypothesis. We said, given the relationship between the biomarker and precipitation and evaporation, we hypothesized that greater periods of aridity on the altiplano are visible in the lake sediments. That's all that this means here. We can literally reconstruct aridity in the lake sediments based on our biomarker approach. And we can talk a little bit about how aridity may have played a role in the collapse of these societies. And now this is a confusing figure here if you don't know a lot about stable isotopes, but let me just point out one important trend. Ignore the x-axis on top of here. Just look at the y-axis. This shows years before present. In our lake core, we were able to go back over 5,000 years. So we have 5,000 layers that we extracted, like painstakingly, extracted these biomarkers from to reconstruct precipitation. And what we found is there was some change throughout the whole record, but there was a dramatic change in these biomarkers at approximately 900 AD to 1200 AD, right at the exact time of the medieval climate anomaly. And this graph here just shows periods of wetness on the left part of the axis and dryness on the right part of the axis. So dry intervals are recorded on this side of the graph and wet intervals are recorded on this side of the graph and dry intervals on this side of the graph. And sure enough, the driest period occurred during the medieval climate anomaly. So there was a massive drought. There was a massive drought in Peru during the medieval climate anomaly. And this drought, which lasted a 400-year drought, that doesn't mean that it didn't rain in those 400 years, but what it means is that they got a lot less rain than normal. Their irrigation systems probably collapsed. People probably starved, and people probably got really pissed off at the rulers of the Tiwanaku civilization because their only goal was to feed their population and probably give them weapons to fight nearby people. We have no evidence of warfare during this time. We have no evidence of mass migration during this time. We just literally see a collapse. And I argue that this drought was so extreme that it reached a critical threshold beyond which acclimatizing meant abandoning state society. And the gradual reduction of lake and groundwater levels profoundly disrupted the production of agricultural systems. And that's what caused the collapse. And I just want to leave you with two more slides, because this is what I think this group really cares about. The reason there was a drought during the medieval climate anomaly in Peru was because this precipitation band changed. Now remember, I told you that that precipitation band known as the ITCZ is related to temperature. During the medieval climate anomaly, this whole region here warmed up a lot. A degree Celsius is a lot. And it caused the ITCZ to move northward. It caused it to move away from Peru because it shifts into the warmer hemisphere. And as a result, it left this area dry. It moved so far north that it left this area dry as well as this area and this area. And those were all societies that collapsed. Tiwanaku, Maya, Angkor, Tang Dynasty. They all existed in this delicate region where precipitation was delivered by the ITCZ. When temperatures warm in the North Atlantic or in the Northern Hemisphere, that ITCZ moves far, 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 far to the north. What's happening today in the North Atlantic to temperatures? Can someone answer that? Does anyone know what's happening to ocean temperatures today? Yeah, you're absolutely right. They're warming. And they're warming as much as it was during the MCA. So today, modern sea surface temperatures are comparable to sea surface temperatures during the medieval climate anomaly. So as a geologist or as a geochemist, I'm often searching for ways to be relevant. You know, like I'm not too interested in plate tectonics. I mean, I like it, but I'm not too interested in that. I don't like rocks and minerals all that much because I don't think like studying them, and this is a jab at those people who do study them, I'm sorry, it doesn't really help modern society. But if we can go back in time and find an interval that is similar to our current warming interval and say, look, this is what happened to society during the MCA, we can warn people about what very likely could happen in the future. So a small amount of warming, even in the North Atlantic, a degree Celsius or so, can have a tremendous impact on these societies that are currently living at the periphery of the ITCZ. This is the last slide. And as I say here, that puts these people at risk, meaning it puts the same people at risk today, just like it put in the same way that it put the people at risk 1,000 years ago. Because even though we have more and better technological innovations that might help deliver water at a more reliable manner, we simply can't fight global climate. We can't. Like if the ITCZ, if the rainy season vanishes in Peru because the belt of clouds that delivers the precipitation to Peru moves so far north that it doesn't really rain there that much anymore, there's literally nothing we can do. There's nothing that they could do. So today, people try and predict this using models. Nerds like myself try and predict this using models. They're even nerdier than me because they know math very well. And I'm saying that they're wrong because we've used their models to predict how the ITCZ moved in the past, and we found that it actually underestimates the degree of shift in the ITCZ. So they're not demonstrating the real problem. They're underestimating what the future problem will be. And that leaves a major gap in knowledge that we hope to fill. So we just wrote a big grant to NASA to study this in our department, to study how the ITCZ will change in the future based on past changes in the ITCZ under similar environmental conditions. And that's why I think this research is important. I think it's important for sustainability because precipitation is part and parcel to sustainability or building a sustainable society. And I hope, you folks would agree with me on that. And I skipped some stuff, but I'd rather just end it here than dragging it out. If there's any questions, I can take them, or if you have any just general stories about field work in Peru, I can talk to you about that. So thanks.
I imagine there might be some on Zoom, but do you want to start with questions here?
It doesn't matter if you have a question. Was anyone interested in this stuff in precipitation a little bit? I'll go Bridget first, and then.
So, do you think the dramatic environmental changes we're seeing now are a result of human precipitation or is it natural occurrence?
Yeah, see that a lot of people say that, which is a good question.
Repeat the
Yeah,
question.
is it picking me up here, right?
Yeah.
Or on yours? I can't remember.
On yours.
On mine.
Yeah.
Bridget asked, is the changes we're seeing now then related to a natural event like the MCA? The MCA was natural for the most part, the change, or is it because of industrialization? And the answer is clearly because of industrialization. But let me tell you all something that I tell my class. I'm teaching this class, another class that I just developed this semester. It's humans in the environment, but I'm doing it completely differently. It's better. Sorry, because some folks took that last semester with me. It wasn't that good. It's good this semester. It was my first semester teaching. Based on like all the natural cycles that we know of that control climate, like the solar cycles, the Milankovitch cycles, Google that if you don't know what I mean. The cycles of glaciation and interglaciation, so CO2 levels in the atmosphere, all indicate that we should be going into a glacial period now, but we're not. We're not going into a glacial period. So that tells me that none of this warming is natural. It tells everyone that too. Did you have a question?
Yeah, what caused the warming?
It's so complex. Next question. It's really tough. We don't fully know, but I'll take a stab at it. So what happened was, you ever heard of the Great Oceanic Conveyor Belt? The thermohaline circulation, the THC. Have you guys ever heard of that? THC. So the thermohaline circulation is a giant oceanic conveyor belt. Maybe I can just do this really quickly. Right? That redistributes heat globally. I might get in trouble searching this. Yeah, I knew that would happen. Ignore this for a second. So here it is. They call it the Great Ocean Mix Master, but it delivers heat from the tropics to the northern poles. And that's also why like England is super warm, I guess you could say, given its latitude. Like if you go straight across like this, England's like up in the Hudson Bay, but it's not freezing like the Hudson Bay is. It's really warm because of these ocean currents that bring warmth to England. And what they think happened during the medieval climate anomaly was that the Atlantic meridional overturning circulation, or the thermohaline circulation, sped up, and it accelerated warmth in the northern hemisphere. And that's like a really short answer. During the Little Ice Age, guess what happened to it? It slowed down. You're so good. Are you a professor here? Yeah, I know. Okay, good. Any other questions?
There's a question online, Professor Wanko.
Yeah, so I have to find that here, huh?
The question is why? Speed up.
Yeah.
Stop it. I haven't, because of the NAO, I think. How do I get, I go like this, hold on. I go to my Nana, who's 99 years old, for tech support, so just be aware. I'm trying to, how do I find this? Hi, Cheryl, how's it going? I don't know how to find your question.
No,
maybe?
no, I didn't put a question in. I was going to speak it.
Okay, go ahead.
So yeah, I'm in the English department, and my initial training was in historical methods. I don't go as far back as medieval, but I'm really fascinated by the proposition that this caused or helped cause the downfalls of certain civilizations. But when I look at the band that the ITCZ, sorry, I had to check my notes, covers, there are certainly a whole lot of other civilizations within that band that didn't collapse.
That's
right?
Yeah.
So I think, you know, as you're proposing this, it might not be like the reason, but it certainly would be a destabilizing, right, component of for a government, for example, that can no longer feed its people, et cetera. Those other, I don't know, governments that may have had better trade agreements or something, they might have been able to get food in other ways in order to keep themselves going. But I just was interested in your response to that.
No, you're absolutely right. So like precipitation delivery to those areas isn't solely controlled by the ITCZ. The ITCZ will then impact, it'll have like a cascading effect on other precipitation regimes. Where's this camera that I should be looking into?
It's yours.
Is it really mine? No, yes, it is. It's Cheryl. So let me tell you something. The ITCZ is just one of these precipitation regimes. And when it shifts, it changes a whole slew of other ones. Like it'll change the position of the trade winds and the westerlies, and those flow in different directions. So while some areas become wet, other areas will become more dry. And also the ITCZ is very sinuous. It's like a snake. It snakes around. And it's a little bit more complex than I'm making it, but certainly having like a buffer, like a societal buffer that's extra, it's external to precipitation, relying on precipitation regimes would help. Yeah, that's exactly right. I don't think we'll ever be able to answer that question, is like, why do some collapse and others don't? But especially if there aren't written records. But that's a very, very good point. Thank you.
Thank you.
Yeah.
That, if I may.
Yeah, sure.
Cheryl, can you hear me?
Can you hear?
Am I being captured by?
Yes, I can hear you.
Okay, I'm over here.
So it's not awkward.
So one question that occurred to me as you were talking about the collapse of these civilizations is that this type of research really seems like it would benefit from working with political scientists and economists and anthropologists and library science specialists. To what extent is the work you're doing coordinated? Because they might be able to answer some of these questions you just said.
Yeah.
Maybe we'll never be able to answer.
So I published on this, and I work with archaeologists and anthropologists. You know, that's really important. And I'm going to show you this paper and tell me, who do you think wrote the first sentence in this paper? Was it me, or was it an archaeologist? And it's a good one. So I want you to, here it is. Here's the first sentence. Human societies exist in a constant dialectic with their environments. I was like, that is not me. That's an archaeologist, anthropologist. It's like straight out of Karl Marx, just replace environment with like classes. And I was like, all right, that's good. I like that. So yeah, Liz Arkush is super smart, and she's a famous Peruvian archaeologist and cultural anthropologist who works in Peru, and she's at the University of Pittsburgh. And I need that. Aubrey Hillman's now at SUNY Albany. Aubrey Hillman's at SUNY Albany, and she's like a climatologist. I'm a climatologist as well, but a paleo one. So she knows a lot more about weather patterns. Yeah, like the more I'm teaching my students now about Earth systems, and the more you can take a systems approach to studying these things, the better. Because like you're both getting at, and rightfully so, I'm a climate environmental determinist, meaning I'm super biased. But you can't just look at a problem from one side. And sometimes it's hard to collaborate, but I thought we got a couple good people in there. So you guys can go, by the way. Yeah, I think I'm sorry. This is so nice that they came here. I'm really mean that, all of you who came as well, but you know, they probably didn't understand it as well. So any other questions? One more.
I could just,
Yeah, I have time for 2 more questions.
Go ahead, Cheryl.
I can ask a tangential question.
Yeah.
Do you, and this is from kind of literary studies, et cetera. Do you know the novel Ishmael by Daniel Quinn?
Of course, I read Ishmael.
Yeah. So he, and in a lot of his other writings, he talks about, you know, the shift, you know, the bad shift from hunter-gatherers to agriculture. And one of his other books, he actually points to the same thing, like these downfalls of civilizations. And he says it's because agriculture failed that civilization. He wants to make that kind of philosophical argument about it, but it supports you.
Yeah, that's why I think he's right. But more to the point, like, but think about it, like we developed agriculture, then we developed towns, and then almost immediately empires. And we had to sustain 60,000 people, like Uruk, the first city, probably had 60,000 people in it. And we had to sustain that. Like, and we couldn't do that without agriculture. So you see this interdependence here. You know what I mean? Ishmael, the coolest part about that book was the beginning. And they're like, you ever notice when like a lion hunts a wildebeest, it kills the wildebeest and eats it. But then all the other wildebeest sort of come back and sort of stand around the lion. Like they're not afraid of being killed by that lion again. Like they just sort of know that the lion just needs one wildebeest. But a human comes out and shoots like something, a game of, they never return because the humans will sort of kill them all. You know, like that's the approach of humanity. That was sort of had a profound, I read it when I was 16, 17, 18, you know, and I was like, oh man, that says something. And I'm still trying to figure out what it says. Thank you. You should read Sapiens too. That's a good one by a professor from Hebrew Nash. He's a professor in Tel Aviv, and he wrote a good book about the history of humans and how we've been causing mass extinctions ever since the beginning. There's a huge misconception that in Native Americans, Paleo-Indians were one with their environment or more one with their environment. And you can people argue with me on this, but I think that's a racist trope because it robs them of a lot of complexity. And the first mass extinction, since Homo sapiens came around, were triggered by Paleo-Indians who came to the New World and hunted the mammoths, mastodons, ground sloths to extinction. We know that. The Maya collapsed in large part, because of deforestation and soil erosion and drought. So that was like more of a 1-2 punch than the Tiwanaku. But you know, they're people. They're people. They have good aspects and bad aspects. So
You also ought to read David Graeber and David was the Dawn of Humanity.
I'll have to read that one.
Yeah, because they kind of take another approach that this whole progression, as it had used to be called, from foraging to agriculture and cities and so on, it's not inevitable because there are the people that the neighbors of the agricultural communities who look at that and say, we don't like the inequality there and so on.
Yeah.
Yeah. So the people in the mountains of surrounding Mesopotamia looked at that. They said,
oh, I could talk about this forever. Yeah. Like we literally noticed a change in the density of the bones of people when agriculture was developed. They became less dense, 25% less dense, probably because of monocrop agriculture, just eating one thing that didn't have all the essential amino acids you needed and other vitamins for bone growth. Yeah, like it's not always been better. Tooth decay increased. Like we see this in the dental records. Our jaws got smaller because we weren't eating meat anymore. We were eating grain crops, and our teeth didn't reduce in number. So we got these gnarly, mangled teeth. Think of the British people. That was a joke. Sorry. Don't think of it. But like that, you know, think of like my lower dental arcade here.
but the fact that people thousands of years ago recognized.
Yeah, but they're
also.
yeah, it's awesome.
And shows different paths, but we don't hear as much about them because they didn't write the history.
Exactly. And they're in trouble now, you know, those societies those people are really being pushed even more to the periphery, to more unstable environments. Think of like the Kung, I think that's how you say it, in Africa, or the indigenous Australians, you know, or think of the Native Americans. Like, there's a reason why like people are miserable on these like areas that we set up for them to live unnaturally. You know what I mean? Like, it's sort of depressing. Like, I was never meant to work in a corporation. If you put me in a corporate environment where I had to like wear a nice suit and tie and follow these guidelines and say, "Good day, governor," to everyone, I would be miserable too. Like, I wasn't meant for that, I guess. No offense to folks who want to do that with their lives, but I wouldn't survive in that situation. And I think it's important for people to realize what's making their life more miserable and try and change it a little bit. I'll leave you all with that.
You have time for one more?
Of course I do, yeah.
Yeah.
If you guys gotta go, seriously, feel free to go, because it's 12:50 now. No,
It'll be quick.
that's fine.
You are studying the medieval climate anomaly, which you said was about 1.5 degrees Celsius.
Yeah.
Different. A lot of projections are that we're gonna blow past that. to 2
Yeah.
degrees, 2.5, 3 degrees Celsius.
Yeah.
Will your research help inform those
Yeah.
types of scenarios?
Yeah, because they're trying to reconstruct precipitation based on that exact change, like, you know, business as usual, reduced emissions, accelerated. And their ability to predict precipitation based on the models isn't good enough. So we can say like, maybe we could even, I don't know if we can, but prognosticate or project is the word I'm looking for, project the medieval climate anomaly to like a double medieval climate anomaly, like a 3 degree Celsius change and so on and so forth. We noticed the north, by the way, let's think about that. Okay, good, thanks. Yeah, it's good stuff.
Thank you.
Yeah, you're welcome. See you guys. Take care there. Good, thanks for coming, guys. Maybe you learned something.
For those of you